Find the value of the integral where c is parameterized by r of t equals 17 sine t, 8 cosine t, 15 cosine t, where t is between 0 and pi. So this is a line integral, and the first thing we'll do is replace x, y, and z with 17 sine t, 8 cosine t, and 15 cosine t. And then ds is going to be the length of r prime of t. So if we take r prime of t, that's 17 cosine t, negative 8 sine t, and then negative 15 sine t. And then the norm of that will be the square root of each of the components squared. So 17 cosine squared plus negative 8 sine squared plus negative 15 sine squared. And then dt, and this will be going from 0 to pi. So we'll simplify. 8 cosine t plus 15 cosine t, that's going to give us 23 cosine t. And then inside the square root, 17 squared is 289, and that's cosine squared. And then this is negative 8 squared is 64 squared, or 64. And then negative 15 squared is 225. So we just need to add 64 with 225, and that's going to give us 289. So we have 289 cosine squared plus 289 sine squared. And so I can factor out the 289 here and say, well, this is cosine squared plus sine squared, which that is equal to 1. So this is just 289. Of course, inside the square root. So then you take that square root of 289, and that's going to give us 17. Okay, so basically, this whole thing turns into 17, which that's going to get factored outside. So now we have 17 integral from 0 to pi, 17 sine t plus 23 cosine t. Integrate this. So the antiderivative of 17 sine t is negative 17 cosine t. And then we have 23 sine t going from 0 to pi. So if I plug in pi, cosine of pi is negative 1. If I multiply by negative 17, I get positive 17. And then sine of 0 is 0, so I'm not even going to bother that. And then minus, now I'm going to plug in 0 for t, so negative 17 cosine 0 is negative 17, and then sine 0 is also 0. So we have 17 minus negative 17. We're going to add these. So this is 17 times 34, which is 578. And that is our final answer.